All right, welcome everybody to the WRS seminar series. Our speaker today is Keith Schilling. He's the state geologist and director of the Iowa Geological Survey at the University of Iowa. And he has a lot of interest in hydrogeology. He does research on a wide range of water resources issues, non-point source pollution, and as director of the Iowa Geological Survey, he helps provide information about subsurface geology and groundwater resources. Today, he's going to talk to us about some of his recent research on nutrient load reductions in restored river oxbows. So take it away, Keith.
Okay, thank you very much. Can you see this screen, Dave? I'm just double checking.
Yes.
Okay, great. Yeah, I'm going to present today on some work we've been doing the last several years, partnering with our colleagues and more in the Fish and Wildlife Service things to look at how to combine our joint interests to look at nutrient load reductions and restored river oxbows. First, let's get on the page here in terms of what oxbows are that we're trying to talk about. Well, if you had any basic geomorphology, you know that oxbows are simply an abandoned river meander that's been cut off from the main channel. They typically arc-shaped water bodies on the river floodplain, connected in some ways through a little elevation difference with the main river. Being in the floodplain, they tend to be saturated where the water tables are relatively shallow, so they maintain their water elevation over extended time periods. If we look at an example, this was a air photo from a river in Texas. I'm not even sure what location it is. This is a photo from 1944, and you can kind of see a typical river meander that if you were flying over on an airplane, you would see. In 50 years later, you can kind of see that meander neck has been starting to cut off and it's closing in on itself. 10 years later, it bypassed through that meander and the meander neck, and now it's forming an oxbow lake. A year later, you kind of see that arc-shaped lake. So that is what we were talking about here, is what are the nutrient reduction benefits of these kind of abandoned river channels. Although I'm going to tell you that what we're doing is actually reconstructing these systems. They're not going to existing ones. The Fish and Wildlife Service has been restoring oxbows in the Des Moines Lobe region for more than a decade, mainly because these abandoned off-channel habitat is the primary location for a federally endangered little minnow called the Topeka Shiner. There's a picture of one here in this gentleman's hand. Kind of an innocuous little fish, but it's driving a lot of work to restore this habitat because they are endangered. The Fish and Wildlife Service and the Nature Conservancy have completed over 100 of these oxbow restorations in Iowa. Most of them have been focused in two watersheds, the Boone River watershed and the North Raccoon River watershed on the Des Moines Lobe. Des Moines Lobe, as you know, is this recently glaciated terrain of Iowa that tends to be flat, heavily cropped, and tile drained. We, at the Geological Survey, myself and a couple others, had some conversations with the Nature Conservancy about some of their work in the Boone River watershed, and we use this as a platform to investigate some of the water quality benefits of these reconstructed oxbows. I'm going to mention two sites that we've done some intense water quality work. One that should be White Fox Creek watershed, which is a tributary in the Boone River watershed in central by Webster City and Des Moines Lobe. And a second one in a county park just outside of Cedar Rapids. So one on the lobe and one off the lobe. The one on the lobe, named after its owner, we call it the Frye Oxbow site. You kind of see the arc-shaped channel that was constructed here, the River Oxbow of the channel. There's White Fox Creek on the right side with another meander bend in it at that point. There's locations of samples that we've collected. We installed some monitoring wells in a couple of transects across the Oxbow. Those are in the yellow squares. And what was unique about this location was this Frye Oxbow site received tile drainage from 2 tiles from the neighboring crop field. So in this case, it was constructed to receive that tile drainage from that field. Yellow arrows give you an idea of the groundwater flow direction. In all cases, groundwater flow entered on the up gradient side and decreased on the down gradient side across the Oxbow. So we had groundwater inputs and outputs from the Oxbow, but there was some complexities involved in trying to understand the groundwater flow direction in the floodplain. Here's a kind of a construction history of the Frye Oxbow site. You kind of see a tree in the background that's highlighted on several images. So before it was constructed, you kind of see some indentation along the floodplain that said that may have been a former river meander of White Fox Creek. That area was excavated and allowed to fill back with water. And you can kind of see that the revegetated along the side. There's mostly a pastured location for this Oxbow site. As part of our characterization, we did some surface and terrain conductivity mapping with the electromagnetic device, and we also did some electrical resistivity cross sections, just focused on the EM information on top. You kind of see that the blue would indicate more conductive layers with a little more silt and clay, and the warmer colors are more heavily sand and gravel. So you can kind of see through that Oxbow or through that floodplain site, it might explain why some of the groundwater flow directions were a little bit different in the floodplain, because I think it was some of that surface water may have been recharged in the aquifer and through the coarser sand and gravel, and then kind of coming back to the White Fox Creek on the down gradient side. So there was some complexities there in the geology that we're able to capture with the geophysics. Over a 2-year period, this is 2014 and 2015, we monitored conditions mainly with grab samples and some continuous flow devices that we had in the Oxbow, on both the 2 tiles entering into the Oxbow. So we had continuous flow monitored, and we had grab samples for quality. Kind of see in 2014 there was a couple large precipitation events in late June, early July, caused the tile drainage to really increase during these 2 months. You can see from the lower left plot on the groundwater depth, you kind of see again we had an influx of water during this time, so some recharge. In 2015, the distribution of tile drainage flows and groundwater depths were a little more evenly split during the course of the year. We didn't have quite those big events that came in 2014. So through grab sampling of a variety of our sampling points, the graphs on the right show nitrate concentrations in 2014 and 2015. By a long shot, the tile drainage concentrations were much higher. They're the ones in more of the stippled lines. You see that they were roughly between 10 and 20 plus milligrams per liter. A little bit less lower concentrations in 2015. The wells were typically much less than the tile drainage concentrations, and the down gradient monitoring wells essentially had no nitrate in them at all. And White Fox Creek in the blue was somewhere in between both the tile drainage concentrations and the groundwater levels. Did a accumulated load plots on the bottom, just saying how the loads increased through the year into the Oxbow. And you kind of see on the 2014, while groundwater inputs were relatively constant during the year, we saw a huge increase in loading associated with those two big events in 2014. In contrast, 2015, the load accumulation was relatively constant all year long. Also of interest to note is the difference between the tile load versus the groundwater seepage load into the Oxbow, orders of magnitude difference. So the vast majority of the load coming in was from the tile inputs and not from groundwater seepage. So in this case, we estimated nitrate retention by doing a daily mass balance on the Oxbow itself. So we were able to capture the nitrate concentrations in from the tile inputs, any surface runoff, and groundwater and precip. And so we could summarize the kilograms per day associated with both nitrate and chloride inputs. We evaluated the groundwater inputs from Darcy's Law, looked at nitrogen chloride ratios, and compared those ratios of nitrate that can be removed due to assimilation or denitrification compared to more conservative tracer of chloride. And then we could estimate the nitrate retention frequency efficiency based on how the ratios on the incoming and outgoing loads varied. And from this work, we're able to look at the nitrate retention in the Oxbow. In 2014, the average retention was 44%. So 44% of the incoming nitrate load was retained by the Oxbow. We couldn't tell you that it was assimilated into vegetation or denitrified. We're just saying that some of it was some likely part of it was both of them, those processes operating. Kind of see how the pattern on the graphs on the right look. The dark gray line is the retention. Saying in June we had increasing retention up to about 50%. Then following the big spike of inputs from the precipitation events, it decreased and then it increased through the fall. In 2015, the retention efficiency was 41%, kind of staying at about 20% through most of the early parts of the summer, then increased to almost 100% by August and September. And seasonally, this is reflected here in this simple bar chart, that we saw greater retention efficiencies in the late summer and fall. So by that time in August and September, the efficiencies were 80 to 90+%. Well, a couple years later, we were still monitoring out there. We're not necessarily, we had some new technology made available to us through these Nitrotax sensors. So we deployed a nitrate sensor in the Frye Oxbow in 2016. And we could use that instead of our grab sampling to measure the nitrate concentration patterns in the Oxbow. So rather than grab sampling every 2 weeks or so, we could look at that nitrate sensor and have values every 15 minutes. So the upper left just shows the nitrate concentrations in the Oxbow from roughly May to November. So it varied from almost 4 milligrams per liter at its peak to significantly less than 1 in August and September. From this, and still measuring the water flux into the Oxbow from the tiles, and then Darcy's Law from the groundwater, we were able to estimate what the tile loads into the Oxbow were on a sub-hourly basis. And you can kind of see in the graph in the upper right the inflow and outflow loading patterns. And without belaboring the point, with this nitrate sensor deployment, during this time period, we're able to see that Oxbows retained about 42 kilograms of nitrate at a rate of about 0.21 grams of nitrate per square meter per day. And the nitrate efficiency during this year was about 35%. Both of these studies were reported and published in the journal Ecological Engineering. The one on the left is the first study that we did, nitrate reduction in a floodplain oxbow fed by tile drainage, and the second was a short communication where we summarized the load reductions in the same oxbow with the nitrate sensor. So let me know if you'd like copies, but you could certainly find them in the journal. So moving off the Lobe now to Morgan Creek Park. It's a county-owned park in Lynn County, Iowa. We're outside of Cedar Rapids. Kind of see in the photo in the upper right that there's a scar you can kind of see in the landscape that had to do with Morgan Creek at one point migrating over there. In the picture below, two important people in this project was Alicia Kenny, who's the one with her arms opened up. She works for the Fish and Wildlife Service, has been instrumental in the design of almost all of these oxbow restorations. And a student, Bryce Haynes, in the right, this was part of his master's project to look at this. So Morgan Creek, again, was off the Lobe, and it's really kind of the first oxbow that the Fish and Wildlife Service has tried to restore that was in a different environment, such as this in eastern Iowa. From the 1930s air photo, you get a sense for how Morgan Creek may have migrated in the past. And then by 2008, some channelization was going on at that point between those two time periods. And Morgan Creek is largely straight, and that channel has isolated and filled with sediment. So in the summer of 2016, you can kind of see this time series of drone pictures from the Morgan Creek Park. The oxbow was excavated in kind of an arch-shaped location or configuration next to Morgan Creek. You kind of see by May of 2017 how the final oxbow looked. Largely driven by Alicia Kenny and her design criteria. I would at one point kind of wonder why they didn't follow the topography a little bit more, but it's still in the same location as the old oxbow was. Bryce, as part of his work, hand-augered a bunch of wells out there, so we do have monitoring wells. We couldn't go upstream or up gradient in this case because the former Morgan Creek had kind of migrated to the channel, to the edge of the bluff, and we were hitting shallow limestone once you worked your way up the up gradient hill. But down gradient, we saw groundwater flow largely to the southeast with the gradient of about 0.004, and the hydraulic conductivity a little bit higher here than it was in the other location, about 4 meters per day. Again, groundwater samples were taken through a grab sampling basis from 2016 and 2017. Not to get into all the patterns that showed up here, but highlighting a couple wells. The wells on either end of the oxbow kind of had definitely more coarser material in them, and they averaged about 2 and 3 milligrams per liter. All the wells in the central part of the floodplain down gradient of the oxbow were actually very low. The stream itself, Morgan Creek, averaged about 8.5 to 9 milligrams per liter, fairly consistent over this entire period. And the oxbow itself was very low at about 0.5 milligrams per liter. So unlike the Frye oxbow, there is no tile drainage coming into this one. This was just fed by groundwater seepage alone. Now, Morgan Creek by itself, it's an active channel in that it floods very frequently. This was a time series plot of stream stage in Morgan Creek based on Iowa Flood Center bridge sensors that were installed in 2011 and are ongoing today. You see that the Morgan Creek exceeds the flood height elevation regularly, and it's done so throughout this monitoring period. We focus more specifically on the period of this Oxbow reconstruction and monitoring. Two big events in 2016 occurred. Both of these events were sampled soon after they flooded, and in both cases, as I've highlighted there, in blue, the dates that occurred soon after those two events. The Oxbow showed some evidence of higher nitrate concentrations after that flooding compared to other non-flood periods. So it was clearly there was going to be some evidence of flood water inputs of nitrate into that Oxbow. In April 16th, to be exact, in 2017, there was another large flood that occurred in Morgan Creek. And the stage went up quite considerably, and the Oxbow restoration was inundated. This is a slight post-flood period, but you can kind of see the elevation of the water surface in the Oxbow is much higher than it was earlier. We estimated that the total volume of water in that Oxbow, based on post-construction surveys and so forth of the bottom, was about 3,500 cubic meters. Nitrate concentration in the Oxbow soon after the flooding was about 5.3 milligrams per liter. And based on the volume and that concentration, we estimated the total load of nitrate input into the Oxbow during that flood event was almost 15 kilograms of nitrate as in. We look at the hydrologic response of the area to this flood. The graph here just shows the hydraulic head and the groundwater, or this is groundwater depth, I guess, in a well near the Oxbow, show that it really did peak during that flood event and then recede. We had stage in the Oxbow itself. Again, at that peak level, it was much higher, and that was how the volume of the Oxbow changed with continued monitoring. So it's slowly, largely seeped out and lost some volume as it infiltrated back into the aquifer. A few days after the flood, Bryce got busy, went out to the Oxbow and installed a nitrate sensor soon after the flood. So a couple days after the flood, and it was safe, he did install a Nitratex nitrate sensor in the Oxbow. It was quite interesting to see. The graph on the left here shows the nitrate concentration decreasing in that Oxbow from initially about 5.3 milligrams per liter to reach the concentration of 0.7 in about 3 weeks, 21 days later. We were able to model this concentration reduction with just a first order equation with the modeled equation there in black and the measured values in green. This is a load reduction, so we're not looking at concentration, it's the load. And from this kind of simple modeling, we see that these two, the measured and modeled reductions kind of converged after that 21-day period. We ended up about 0.3 grams per square meters of nitrate per day with a load retention efficiency of 74%. Now those curves aren't going to be perfect because this is clearly an open system. There's other inputs of N during this time in terms of like fish or birds and things like that. So there's other sources of N. It's open to the atmosphere. There's a lot of things going on. So this will never have that same first order laboratory test tube kind of response, but it did seem to describe the converge at that level after 21 days. What was interesting also is that Bryce there in the left with the Fish and Wildlife Service person were able to do a fish survey of that oxbow soon after the flood. It was kind of interesting to see during the other two of times when that flood waters have encroached into the oxbow, the flood was essentially connected to the oxbow for a total of 46 hours over this since it was constructed over a 6-month period. And you can kind of see from that floodwater contribution alone, the fish population that had was sampled during this netting. Really kind of remarkable in my eyes that they even had a first or second generation spawn occur during this process. So the floodwaters, sure they brought in the nitrate load into the oxbow, but also brought in a lot of fish species as well. And Bryce was able to document other habitat uses soon after it was built. Again, it looks even more beautiful today from crayfish, turtles, and of course bird usage of this oxbow. We published this paper in the Journal of Environmental Management, again trying to document the effectiveness of these newly constructed floodplain oxbow to reduce the loads, in this case from a spring flood. Now this really sets the stage for this comparing of these oxbow sites, because they're similar and different in important ways. First off, the Frye Oxbow is on the Des Moines Lobe. Morgan Creek is in an older southern Iowa drift plain pre-Illinois landscape. Their watershed sizes, similar. Stream nitrate concentrations were higher on the Des Moines Lobe and Frye Oxbow compared to Morgan Creek. The excavation size was very similar between the two. We had actually more groundwater seepage in a slightly coarser textured alluvium in Morgan Creek than the Frye Oxbow. Monitoring wells and the nitrate concentrations in the monitoring wells were higher in the Frye Oxbow right next to the crop environment compared to Morgan Creek, which was really low. Now the important difference between these two systems is how the nitrate load got into the oxbow. In the case of the Frye Oxbow site, the vast majority of the nitrogen was delivered from tile drainage, ranging from 42 kilograms per year in one of the years to 470 kilograms per year during a high flow year. In contrast, Morgan Creek only saw nitrate during a flood event. Now the nitrate retention efficiency was less in the Frye Oxbow, mainly because it just saw so much greater load. And the Morgan Creek, with just a one-time shot of nitrogen during a flood peak, had a much higher retention efficiency. Cost-wise, the Frye Oxbow was about $15,000 to build, as opposed to almost double for Morgan Creek. The Frye Oxbow could be a little more typical. The Morgan Creek was in a county park, and they wanted the county wanted the excavated material for another project. So most of that cost was associated with the trucking costs of the removal of that material. In these floodplain sites, if you get a chance to just you have to get the fill out of the floodplain. You can't dump it in the floodplain itself, but you can essentially, in the Frye Oxbow, if you set a backhoe up, dug it in the floodplain, pivoted the excavator, and dumped it out of the floodplain, there would be no trucking costs whatsoever. So costs tend to be around $10,000 or $15,000 for these. It's kind of a parallel effort along this water quality monitoring. We've been trying to look at how to better identify where reconstructed oxbow sites could be located. I'm not sure about Minnesota, but we have at least one round in 2010, around that time, of high resolution LiDAR. So students both at Iowa State and University of Iowa collaborated to use this LiDAR coverage to identify potential oxbow restoration sites. Kind of see from these two images there of a typical stream channel migration and then this filtering process. So if you fill these depressions, you get a lot of extra depressions showing up. So it took some real effort to try and figure out how best to filter these shapes to find these potential oxbow sites. And Courtney at Iowa State, here's a paper again that we published on this process, which was this GIS methodology to identify oxbows from LiDAR DEMs. From this process, we're able to locate potential sites and then rank them based on their probabilities that they were actually oxbow sites and not just a random depression in the floodplain. So we could use this GIS process to quickly screen this entire watershed to find potential oxbow sites. And from doing that, it was clear that there's scores of potential oxbow locations just in the Boone River watershed. So there are a lot of opportunities for oxbow restorations to kind of reintegrate some of these hydrologic features in the landscape. Now, where I come in also is thinking about how these reconstructed oxbows can serve as a best management practice for nitrate reduction. In Iowa, likewise, other upper Mississippi River states have developed nutrient reduction strategies. And in Iowa, BMPs for tile drainage typically include practices such as bioreactors, drainage water management, wetlands, and saturated buffers. What we feel is that these reconstructed oxbows are probably best comparable to bioreactors based on the treated area and the cost. So both of these are treating areas that are roughly 20 to 40 acres of tile drainage, and both cost on the order of $10,000 or $15,000. So the bioreactors typically have a nitrate reduction performance of about 43% reduction, which is very similar to what these reconstructed oxbows. But what we're finding, especially with the Fish and Wildlife Service and then other partnerships, is that landowners are particularly interested in these oxbows because of the wildlife response, the fish and the waterfowl, especially if they're fishers and hunters. And also because this is land that really was fairly marginal to begin with next to river channels. In cases like that Frye oxbow, that oxbow is serving as a watering location for occasional livestock. So we're seeing a lot of landowner engagement for oxbows as a potential BMP. And along these lines, myself and my partners, Karen Wilkie of the Nature Conservancy, Clay Pierce at Iowa State, works for the USGS and their co-op program, Keegan Culp, who had worked for the Iowa Soybean Association, now works for the Drainage Water Coalition, and Alicia Kenny from the Fish and Wildlife Service. We all collaborated to propose a new practice for the Iowa Nutrient Reduction Center. And we went round and round on a name, but we called it a multi-purpose oxbow. And we decided on this name because the oxbows are really put in for dual purpose. And we're saying that as an approved practice, they should have the dual benefits for fish, including the Topeka Shiner, and for nitrate reduction. And really the most efficient way to use this practice would be to engineer them so they receive tile inputs to maximize the N reductions. Now we can certainly put oxbows in all these hundreds of locations, but they're not really going to be an effective nutrient reduction practice until they see enough nitrate to be worth the effort for that. So that's where we decided that if we were going to offer this as a proposed practice, as an improved practice now, they need to be engineered to receive the tile inputs, just so they see enough load. And we published this paper just recently in Agricultural Environmental Letters, where we lay out our criteria and our case to be made for multi-purpose oxbows as a nitrate reduction practice in the agricultural Midwest. And you kind of see from a recent screenshot of the nutrient loss, nutrient reduction practices in Iowa for nitrogen, you kind of see here on the bottom, on the edge of field practices, that this multi-purpose oxbow is now listed along with wetlands and bioreactors and buffers as an approved practice, with a nitrate reduction rate of 42%, with a standard deviation of about 6%. And that was based on the monitoring that we've done in the Frye Oxbow site. Now, to put this case together, we had to develop some design features and performance and cost considerations. So this is just a rough summary of some of the factors that we included in some of our analysis. So these are, we're a long ways yet from having the official NRCS design specifications, but we're working towards those. But for Iowa Department of Agriculture and other folks interested in installing these multi-purpose oxbows, we thought that they should be designed to fall within the typical wetland sizing. So they're not going to be too large and not really function for their dual purpose of the for the Topeka Shiner and the habitat. They should be connected in some ways to the river channel, the stream channel. Usually be connected on a typical flood frequency of 1.5 to 2 years. The best oxbows for these conservation tend to be smaller in size, about 1/2 acre or less, and have a depth equal to about the depth of the adjacent stream channel. Oftentimes when you build these, as you're excavating, you'll see the old basal lag deposits of the river channel, that the meandering stream system, and that's usually the depth that these will be built. So they can maintain their water connections to the river and water levels year round. Sedimentation rate has been typically very low so far, about 0.4 centimeters per year, mainly because they've been built only to receive floodwaters during larger events. They're not, there was one failure that Alicia had where at that point, while she was still learning the process, she connected the oxbow on the upstream side instead of the downstream side, and that one has received more sedimentation. And these multi-purpose oxbows can process tile drainage from a typical 20 to 80 acre farm field, similar to a bioreactor, and the typical cost, like I said, between 10 and 30, mainly based on the disposal costs of the excavated material. Now, lastly, we have been funded by the INRC to continue some of this work, and in partnership with Iowa State University, here at the Geological Survey, we're managing the water quantity and the loading and the load reductions. Iowa State, through the leadership of Clay Pierce, is looking at the fish and habitat sampling. And in this case, we're looking at paired tile-fed and non-tiled oxbows in the Des Moines Lobe region. So we're able to compare, does tile drainage affect some of the fish in the habitat, or does it, how do those factors work together? And we have nitrate sensors in both the tile-fed oxbows. The non-tiled oxbows, like the Morgan Creek one, just never really has much high nitrate anyway that could not be captured by grab sampling. ISU has been focused on the fish sampling and so forth. They're sampling multiple sites, not just our 4 that we're doing the water quality monitoring, and they're collecting. You can see thousands of fish from these different oxbows, and both paired and tiled and non-tiled oxbows with occurrences of Topeka Shiner in 7 out of the 12. So this is ongoing. We're just completing our first year of monitoring in many cases, and we got another year left to do next year. So with that, I think I'm about on time. I'll be happy to take any questions that you might have.
Thank you, Keith. That was really great. See, I had one question. Have you ever seen any phosphorus related problems with eutrophication?
We haven't, because we haven't really looked. We have added phosphorus for our new the new project that we're looking at. So give us another year or two on that. We'll have better answers for you, but we have not really looked much at the phosphorus.
Okay, I'll ask about the connection to the nearby channel. In your list, it indicated for flow, bankfull discharge type of situations, you the design would consider allowing that water to enter into the Oxbow. And I'm just wondering about the reasons behind that. Maybe you talked about it during the presentation, but I must have missed it.
Yeah, I think I probably glossed over that. So there was some, if you want colonization in this oxbow, there's got to be some level of exchange of fish and so forth during, an occasional event. So the balance was, how often do you want that exchange to occur, and then for how long? So again, these are largely guidelines that are based on kind of rules of thumb, kind of an approach. But the thought was that let's connect them so during their annual or biannual flood peak, there's opportunities for exchange of fish across that interface.
Go ahead, Philip.
So I know you're not in like a steep slopes overlay district where you are, but is there any worry about like channel formation, gully formation, those tile drain oxbows becoming unstable drainage features, anything like that, where you might start seeing increases of TSS, like headward erosion and hill slope erosion with the construction of that, or?
At this point, no. I think you'd have to be careful to not put them in locations that might be prone to that. These tend to be a very flat, floodplain setting, and there is not much of a slope there. So the tile drainage actually is typically, dumping right in or falling right into the oxbow itself. So there really isn't much of an opportunity for that gully headward erosion with these features. Now, if it was running off into the oxbow across the land, yeah, I think there'd be opportunities here. But this is more of a, at the outfall of the tile rather than running across the land into it.
Do you put any like riprap or anything at the end of those tile drain, like outfall pipes at all, or?
I think there's some consideration for that, to be honest. That has not been a huge consideration. I think a couple of the newer ones, depending on how the tile might have come in. The vast majority, to be honest with you, constructing these to receive tile drainage is kind of a new direction. So through Alicia's work with the Fish and Wildlife Service and the 100 oxbows that were put in, nearly all of them were not put in with tile drainage in mind. So this is a new direction to try and gain these added benefits because they can essentially be sold as part of this nutrient reduction strategy idea, so we can get even more out there. So at that time, there was concern about the the nutrient loads coming in and how that might affect the fish and so forth. So this has been a kind of a new direction, and I think there's still some learning to do about how to build these correctly.
Thank you.
One of the issues with this tiled and non-tiled was we were posing was, you know, whether there was some difference in water temperature because of the cool tile drainage into these oxbows versus the non-tiled. And so far, I think the tiled systems are about 2 degrees C cooler on average than the non-tiled ones. And whether that, you know, the Topeka Shiner typically loves these kind of off-channel, you know, I would call kind of murky, warm water systems. So there was a question about whether they would, you know, how they would do in a cooler setting. So far, so good, but it does look like the tiled ones might be a little bit cooler on average than the non-tiled.
Hey, hi. It's a really interesting project, but I was wondering, do you have to maintain it after a certain period? And if you do, how much cost would you expect to?
Well, I think these are largely thought of to be, once they're constructed, really little to no maintenance. Again, with some of the fish requirements, there's been some effort to clear a lot of the overhanging vegetation because some of that, you know, tree canopy and the leaves and tree litter from that can cause some BOD issues there, you know, and cause some low oxygen conditions. So they do tend to want to make these a little bit more of a grassy riparian zone than tree line. So there's that. Maybe as a landowner, you might want to keep the trees from growing out and cover it and shading it too much. But otherwise, they're designed just to be built and enjoyed, and you know, let nature take its course.
So you don't have to reconnect the channel after a certain period of time?
Well, again, we're in this kind of the new phase, so
Okay.
we'll check back in about 20 years and see what they look like. But at this point, all indications are when they design them in this way, especially on the downstream end, that they've been holding up very well.
Okay, cool, thanks.
I'm curious about the Topeka Shiner and its role. I'm not questioning that it's not important in the ecosystem, but you know, what is pointed out as being the main, how important it is in the food chain and so on.
Yeah, that one, I'm probably not your best source of information on that. I mean, they are, you know, tiny little fish species. I think they're important, like all endangered species, about preservation. So, yeah, I probably can't answer the food chain value judgment on it. But I would say that I think these, you know, these oxbows are a good deal, and they're good to get back on the landscape. And if this is the motivation to get these water bodies on the landscape, I'm not going to look that gift horse in the eye. So I don't know enough about the ecological value of the Topeka Shiner to comment too much on that.
As a potential ecosystem service, to build on John's observation there, I'm just wondering if they might feed on mosquito larvae, if some of these quiescent ponds are adding some sort of breeding infrastructure for insects.
They certainly might, and I know part of the Iowa State group is doing a very intensive benthic macroinvertebrate survey, so maybe we'll see some of that showing up in their analysis. Now, like I said, with the landowners are probably ambivalent at best on the Topeka Shiner, but they certainly enjoy the habitat. You know, I'm not sure anybody's going to win any prizes by fishing these things, but the fish is nice for you know, younger anglers, and also the several hunters have really appreciated the refuge that these oxbows provide for migratory waterfowl and so forth. So they're definitely ecosystem values beyond just the Topeka Shiner.
Any other final questions?
I did have a question, one more, and that was I didn't hear what you said about the temperature. I mean, I know you talked about their lower temperature, but I didn't know what the number was. Was it 3 degrees or was it more than that?
The data I was just looking at was 2 degrees C.
Okay.
Probably based on this year's monitoring alone. So again, it'll be a 2-year project. We'll have more data than that. So that's the early line.
Mm-hmm.
I don't know if there's been any movement on this sort of thing in Minnesota, but I know that they've been looking at restoring oxbows in southwest Minnesota. They've been very active in that area as well, through the Fish and Wildlife Service and so forth. So I do feel these multi-purpose oxbows that I described can be a real win-win for a lot of things that we're all involved with.
I think, Philip, you have a question.
Yeah, I guess so when you guys are reconstructing these, so you're doing it based off the old meander channel, like what channel characteristics are you looking at when you're reconstructing it? Are you just going off the apparent geomorphology, or are you looking at making it a more stable channel, or kind of how are you guys like deciding how you're going to reconstruct it? So it looks like the first one, the Frye one, was kind of like a B-type entrenched channel. Is that just kind of based off the general morphology you kind of saw there, and kind of arbitrary how you dug it out?
Yeah, that's a great question. So it kind of gets at why I think identifying former meanders is more important than just like digging a hole in the ground next to the stream, you know, because there's some connection of that channel at some point, you know, and I feel like you're not necessarily you know, putting one in where it's makes no sense hydrologically. So that's one reason I think to really look for where these abandoned meander scars are in the landscape as a guide. Now, the river morphology wise alone, I think by the time you cut these down to the elevation roughly of the stream channel itself, I mean, there's some limitations, I think, in terms of how to integrate these necessarily with the existing channel. But I would definitely take your point that I think that's just a really good reason why you want to integrate these into the existing stream system where they may have been located in the past.
Are you kind of then kind of forced to make them entrenched then, just to get it down to that current stream elevation? Is that just kind of like has to happen to?
Yeah.
Okay.
Yeah.
Cool. Thank you.
Well, thank you very much, Keith. That was a very interesting seminar, and appreciate your efforts in educating us about your research. It was really an intriguing topic.
Oh, thank you very much.
Everybody give Keith a virtual clap, I guess.
Yeah.
Thank you.
Thank you, Keith.